Hello, everybody. How's everybody doing? I can see messages in the chat from people. So what we'll do is we'll wait a couple of minutes here, give people time to stream in. And then I'm just going to check whether YouTube and LinkedIn is working fine. And then once that's all figured out, then we can get started. Where's everybody tuning in from? Hey, Carlos. Hey, Chris. Hey, everybody. Noah, Merrick, Christopher. Germany, Texas, Montreal. I'm in Toronto. I'm pretty close. Hello from Belgium, Costa Rica, Colombia. All right, so I just got the green light that we're okay on YouTube, which makes sense. Let me see if we're good on LinkedIn. Oh, we have people from everywhere. It's awesome. Dominican Republic, Bangalore, Pakistan. All right, so let me send a message here. Hey everybody, we'll just get started in a couple of minutes here. Let me get the green light for LinkedIn, and if we're projecting well there, then we can get started here. All right, so we're good on LinkedIn as well. So we'll get started now. Oh, George might be rejoining. That's fine. Okay, so what we'll do is let me put you guys on the other screen right now. So we'll go around and 1 second, I'll do a screen share here as well. All right. Okay. So we are good to go there. George might have dropped off. He might be having technical difficulties, but we can get started and then he can join us later on as well. Oh, he's right here. Okay. Welcome back, George. Right. So we'll start off with introductions and then I'll go into a 30-minute presentation. I'll try to keep it short. But what I really wanted to do was just spend time with the fine-tuning team, talk about questions that people have, people that are building with language models. And so we'll go into a discussion Q&A session. As I'm going through the presentation, if you have any questions, feel free to drop them in the chat. The fine-tuning team will be there. They'll answer it. And if there's some really interesting questions, then we can have a discussion near the end. So we'll have about a 30-minute presentation, and then we can have 20 minutes, 25 minutes to discuss things and answer questions that people have. So let's start off with introductions. I'll start off with myself, and then we can go around the table. My name is Zan. I work on the developer relations team. I'm a data scientist. I worked as an engineer before, and I've been working in DevRel for about 2.5 years now. Specifically in the language model space, I used to work on rack systems with a vector database company, and then I started working at Together about 4 months ago. I've been learning a lot about fine-tuning inference engines, especially working with this fine-tuning team. I think learning about the ins and outs of fine-tuning. So for this presentation, what I did is I assumed that people don't know the internals of how fine-tuning works, and then I'll so that we're all on the same page, and then I'll try to give an overview of some of this technology in 30 minutes. Right? So let's Artem, maybe George, you guys can introduce yourself, and then we can.
Yeah, let's. I would like to start. Hi, my name is Artem. I am working in fine-tuning API team at Together. and I'm living in Amsterdam. So everybody from the Amsterdam, I'm here with you. I'm streaming from this is kind of place. Before Together I worked in several startups related to creating chatbots or voice assistants, and also in this kind of situations we need to do a lot of fine tuning, and there's my expertise and all of my stuff were related to. And like today we will discuss several fine tuning features that also related to chats support, and you may have some questions. Feel free to left in the chats and we will answer them.
Awesome.
Right. Yeah. My name is George. I work with Artem in the same team with fine tuning. We do training, we do adaptation of models, we do also service to support any size of the models, any size of the data set in our service. I enabled large model fine tuning and long context fine tuning recently in our team. Before Together, I worked at Big Tech at Snapchat, and I was doing chatbots and diffusion models. So yeah, basically, I think the recent progress that we got in our service showed some really good, basically, results, and we are happy to show some of the recent breakthroughs today.
Yeah, this is one thing that I specifically wanted to talk about, like the long context fine tuning. I have some questions for discussion at the end. We can get back to, but let me just take some time, introduce people to some of these new releases and experiments that we ran that you're talking about, and then we can come back to this discussion. So I'll take you guys off the stage for now, and then I'll add my screen here, and then we can be off to the races. All right, so let me reset it here. Okay, so we get a big screen. All right, so let's get started. We've already done introduction, so I won't go through with this, but I put this here because if people want to connect with me, feel free to scan that QR code. And if you have questions afterwards, or if you're building with our tools and APIs, and you have questions, or if you want to talk about it, I'm more than happy to have a one-on-one chat. So just add me and send me a message. I'd be more than happy to take a call. Okay, cool. So what I wanted to discuss in the next 30 minutes is fine-tuning language models, right? So what does it mean to fine-tune language models? So this is a really funny meme that went around. And so the whole idea is that these language models are these powerful beasts that have been trained on and have consumed the entire internet, and they know everything that's publicly available. And so you've got this base model that comes out of this kind of hundreds of millions dollars worth of training on GPUs. The idea of fine tuning is to essentially put a mask and to control the power of these language models, make them useful for your specific task and not for all the tasks that everyone could possibly have. Right? And so the idea is that you've got this trillion, potentially even larger parameter model, and we're tuning it to control its power and make sure that it behaves more reliably, behaves better for the problems that we care about. Right? And then you also have an additional stage where you make it act nicely, make it nice to chat to, right? So effectively what we're doing is we're fine tuning these things to potentially be friendly. If you want to have conversations with it, you want to make it chatty. Mainly you want to adapt it to your domain, right? So if you take a general purpose language model, um, it won't it might not be particularly good in the finance domain or the healthcare domain. It might not talk to customers the way your customer success team talks to customers, right? So if you want to do domain adaptation, that's really what we're changing the parameters of the model for, right? And in general, we hope that after this fine tuning phase, we make the model more useful for our specific task. And so we'll discuss this, what goes into this fine tuning process. Another thing, so over the course of this presentation, I'll cover multiple notebooks that we've put together, multiple blog posts. Everything is open source, the code, the experiments, the data set we used for those experiments. So I'll share everything, and I'll also share the slides afterwards so that you can run the experiments when you want to. Okay, so let's get into it. So I want to start off from the fundamentals, from the basics. What are we training language models to do, right? So effectively, language models are just next word predictors. So the idea is that if we give them two words like so, the robots, the job of the language model is to predict the next word. Right? And so here it'll give us a probability over all of the possible next words. And then we have some sort of algorithm that samples from this, right? So uh, oftentimes we'll pick out the one that has a higher probability, and then we just run the process over again, right? So now this is our sequence, and then we say, okay, given these three words, what is the next possible word? Or as you can see here, it's not always words, it's word pieces, these tokens, right? So what's the next word piece that's the most likely? And this keeps on going in this sequential autoregressive manner, right? And so language models just need to do next token prediction. Um, and the idea is that if you can predict the next word well, then the only way that you can do that is if you understand the actual process that generated those words, right? So if I gave you a textbook and if you could always predict the next word of that textbook, then I can assume that you have a pretty good understanding of the material in the textbook, right? Um, and so our goal is if we give this thing a big chunk of the internet and it can accurately predict the next word for the majority of it, then it's captured some reality or some information about this world, and it becomes useful to us. And so when we train these very large language models, there's typically a three-step process. It's there's more steps that are being created now, but typically there's a three-step process. The first step is the longest, so this pre-training phase, where we basically take a big chunk of the internet, trillions of words, trillions of tokens, and we pass it through the model, and we see how well it can predict the next word. And we keep on tweaking the billions of weights until it can get better and better at this next word prediction task. This takes the majority of the time and the majority of compute and money. Um, and so this is from that meme. This is the creation of this really large, really capable base model. The next step is to do supervised fine tuning. And so the idea here is you hire a bunch of people to answer important questions that are important to you. And you take their answers and you make the language model output those answers in that style, in that way. Right? And so this is the next phase of the fine tuning process. And then the last phase is this idea that you want the model to uh, respond preferentially. You want it to you prefer specific responses, and you want it to lean more towards those responses, right? So you want to reinforce specific responses, and you want to discourage other responses, right? And so that's the kind of the cherry on top afterwards. When we talk about language model training, fine tuning in this case, we're only going to be talking about supervised fine tuning. Right? So we're not going to talk about pre-training. We're not going to talk about reinforcement learning. We had a previous webinar actually on pre-training, but for this webinar, we're only going to talk about supervised fine tuning. Okay, so if you want to think about what our data looks like for supervised fine tuning, you have raw text. So you can think of this as a snippet from the internet. What the language model really sees is a bunch of tokens, right? So this could be the first token, the second token, the spaces are part of the tokens as well. And each token gets indexed into a number, right? So this is token number 32, token number 7,124. The more common the token, the lower the index typically. And so you basically take text and you turn it into a list of numbers that the language model can be trained on. And so the idea is that if I give the language model 32, 7124, 3611, how likely is it to predict the right next number, which is kind of connected to this particular token. Right? And as we train it, it gets better and better at this, and it becomes more useful for general purpose tasks. Okay, so specifically for this task of supervised fine tuning that we want to perform, and we'll actually fine tune a model as well, what does our data look like? So typically we take questions that we're interested in and we give it to human labelers, contractors, and they give us these answers. And we instruct them on what types of answers we want, what are the rules, what they can do, what they can't do. And so if you're interested in how these data sets get created, there's a really good talk by Karpati. It's a 1 hour long talk. You can have a look at that. But there's a lot of money that goes into getting really high quality responses. This is quite different from the first phase where you're basically taking a big chunk of the internet. You're doing a little bit of filtering, but in this case, you want humans to write these answers so that we can control what the language model is learning, how it's answering things, and so on and so forth. So when we launch our fine tuning job, we're going to be inputting data that looks like this. And so if we get even more deeper into what the data set looks like, it's effectively an Excel file, right? We've got inputs where we've got instructions. These are the questions that a user might give to our language model. So this is a math problem. This is from a math data set, which is linked over here. And so this is one data point of input, and then you have the corresponding output. Right? And what we want to do with this fine-tuning, supervised fine-tuning process is if the language model can output this sequence of tokens, then we know that this is the right answer, right? The human generated this, or or a language model generated it, and we validated that it's correct. So this is one data point, and you have thousands of these, but potentially 20,000 plus. You've got a lot of these examples that you want to teach the language model to answer. And it's still doing next token prediction, but now it's doing next token prediction where the next tokens are generated by humans. And so before you fine tune a language model, it'll give you very generic responses. So for example, in the healthcare domain, if you ask it a very specific question to diagnose something, you might not get an interesting answer. You might get a generic answer. But if you take that very same model and you fine tune it on the medical domain, then you'll get very specific details. It'll know the difference between different types of allergies and different types of symptoms. And so that's the difference between a base model versus a fine-tuned model. Another way to think about this is for diffusion models. If you give the same prompt to a base diffusion model, so here our prompt is circular window in living room looking out into space, you might get something like this. But if you take that same model and if you fine tune it on images of food, the same prompt might give you something like this, right? So you can still see how it kind of makes sense, but now this is preferring to show you things about food because it's been fine tuned to act in a particular way. And so this is the idea of how you're changing these models via supervised fine tuning. There's a lot of use cases for fine tuning models. So the main one is adapting fine tuned models to your particular domain. So whether it's finance, healthcare, legal domains. Another big application is this idea of synthetic data generation, where you can get very large language models to generate questions and answers. And then you can tune a much smaller model to behave like the larger model by mimicking the answers of the larger model, right? So it's not really model distillation, but you're just training the small model to answer like the big model answered. And then there's also systems where you can create a system of language models where you have one task that is broken up into subtasks, mini tasks, and you've got individual fine-tuned language models that are fine-tuned for that specific purpose, right? So if you have a coding task, you might have a language model that's fine-tuned to generate code. You might have another language model that's fine-tuned to output tests for that code. You might have a third language model that's fine-tuned to plan out what the process should be, what the solution should include, right? And you can give that same problem into those separate models and get potentially different answers. And then I've also released an example notebook that you can look at here where I do this kind of routing to special models that if you're interested in this. Okay, so what I wanted to do now was actually launch a fine-tuning job. So before I got into fine-tuning language models, one of the main issues I had was it was not very accessible, right? Whenever I thought about fine-tuning models, I thought, oh, I don't know where to get the data from. I don't know how to fine tune. I don't know of an accessible way to fine tune. There's lots of solutions out there. But hopefully what I want to do is show you how simple it is, and we can do it in the next couple of minutes here. And then you can go back and you can run this code with me, but then when you go back, you can try it with your own data set as well. So the link is accessible over here. You can open it. And then another thing that you can do is you can open it up in Colab over here. And you can run the Colab as is. The only thing that you'll need for this Colab is a Together API key, which you can get from the account. So you can make an account over here, log in, and then you can get your API key. But the code notebook should be runnable as is. Okay, so in this code notebook, I talk a little bit about what LoRA is. We can ignore that for now. I'll cover that later. But the main idea, and so I've got this running on my local machine, which I'll cover here. So the only thing that we're going to need for this is the Together Python SDK. We're going to go in, initialize a client. I also have a weights and biases key here because if I launch a fine-tuning job, I want to be able to track and monitor what's happening and look at the loss curves afterwards. Right? So we're going to initialize that. In this case, our data set is a very small data set because this is a toy example. So this one only has 10 inputs and 10 outputs. And that's going to make sure that this fine-tuning job finishes while I'm talking here, and it doesn't take hours. Right? This will typically be a lot longer, a lot bigger. The first thing that I'm going to do is upload the file to Together to my Together account. So because it's quite small, it uploads immediately, and I get the file ID. So I store that, and then I'm going to launch my fine-tuning job. So here, there's a bunch of parameters that you can look at, and you can look at the docs for this as well. But probably the most important one is to choose which model you want to fine-tune. So here I'm going to use the 1 billion parameter Llama 3.2 model. I'm going to pass in my weights and biases key. I'm going to choose how many epochs to train for. I'm going to turn on LoRA, and I'll talk about what LoRA is in a second, and then I'll give it a name over here. You can also set your learning rate over here. So if you run an experiment and it's not converging, or the fine-tuning is not going well, you can play around with the learning rate. But once you're happy with this, you're going to submit the fine-tuning job. And once that's submitted, you'll get a string here, and when the model is fine-tuned and ready, you can actually use this string to run inference with it. But another thing that you can do is once this job is launched, you should be able to come here into your Together AI dashboard, and if we go into jobs, you can see it over here. So this is currently running, and it's fine-tuning, and so I'll just leave that fine-tuning. I'll go back to my presentation. When this is ready, I'll come back here and we can run inference with this particular model. And so if you want to run the code, you can scan that QR code and you can run it along with me. But I'll come back here once that's done fine-tuning. Okay, so while that's fine-tuning, there's a couple of topics that I wanted to talk about. The first topic that I'll talk a little bit about here, and then we can open it up to discussion to the rest of the team here, is typically when people want to use a language model on their own particular tasks, on their own domain, or on their own data, the main question we get is, should I just do retrieval augmented generation, or do I need to fine tune the model? Right? Which one is going to perform better? What are both of these tasks good for? Right? And so there's a paper that's done on this. There's multiple papers. This is a very hot topic. This is a debated topic, not just in industry, but also in academia. Different people publishing different topics, kind of addressing specific use cases. So in agriculture, for knowledge injection, for knowledge that's scarcely found in the pre-training data. So there's a lot of material on here, and this is why I wanted to open it up for discussion with the fine-tuning team. But let me just give my thoughts on this, and then we can let the team talk about it as well. So this is typically how people think about RAG versus fine-tuning. So you've got a decision to make here, and on a high level, typically if you want the language model to know something new, then you can just tell it. And that's what RAG is, right? It's a very, this is a very simple statement that captures what RAG is. The language model doesn't know about my company policy, so I will put my company policy into the context window of the language model, and it can reason over that. If I want to, if I want the language model to behave in a certain way, then I will change the parameters of the language model. Then I will fine tune it in a certain way. If I want it to talk to my customers the way that my customer success team talks to our customers, then I'm going to give it inputs and outputs where the outputs are similar to how my customer success team talks to my customers, right? So if I want to change the behavior or the style of the language model, then fine tuning will solve the job. If I just want it to know something, then that's what RAG is good for, right? So if you want to inject knowledge, then you go with RAG. If you want to fundamentally change how a language model behaves or it answers, then fine tuning is much better for this. And I also have problems with the question actually. So people ask, should you fine tune or should you RAG? I think the question should be, can I fine tune and RAG? Because I don't think they're mutually exclusive. And so really the story should be something like this. Right? You can use both, and they're just tools in your tool belt to solve the problem that, at hand. Okay, so we'll talk about that. We'll talk more about that later, but I also want to talk about LoRA now. So when we were fine tuning, oh, there's a typo here, but that's fine. When we were fine tuning our language model, we turned on LoRA. I want to show you what that does and how that works. So let me explain by analogy. Imagine each one of these screwdrivers here is a separate language model, right? You might have a plus screwdriver here. So this might be your coding model. If you, for every coding task, you send it to this model. You might have a model that is a specialist in multilingual tasks. You might have a language model that's a specialist at reasoning, right? So you've got all of these different models that you can route to, and you can even fine tune on top of this, right? The difference is that so if you look at all of these models, they're pretty much all the same except for the kind of uh, the tip, right? That's where the functionality changes a little bit. And so the idea behind LoRA is, instead of trying to change the entire tool, what we're going to do is keep the base tool exactly the same, and everything that we want the language model to learn, or how we want the language model to defer through the fine-tuning process, will be captured in these small LoRa adapters, as they're called. And what this means is, now when I'm running these language models, I can have 7, 8, 9, 10 different fine tunes, and I can add this bit to my base model, and now I've got a specialized model, right? If I find that for the second language model call, I need this fine tune model, I can add that, and now I've got a completely separate specialized model where maybe 99% of the parameters are exactly the same. And I've got the specialized parameters that capture the information from the fine tuning data that I'm now using as well. To go into a little bit more details here, when you're full fine tuning a language model, what you're doing is you're learning how every single one of these weights should be modified, right? So for my 1B parameter model, if I was doing full fine tuning, I would need to maintain the direction and the magnitude in which every one of these 1 billion parameters are changing, right? So I would need to have my 1B original parameter weights, and then I would need to have an update matrix of 1B parameter weights that I can add to my original weights, and then I get my fine tune model. What LoRA says is, instead of maintaining every single update to every single weight, maybe what we can do is we might not need each update to be independent. We could learn a rule that says each one of these 5 million parameters are going to update in a certain way. They're not going to be independent. When this parameter doubles, this other parameter will half in value, right? So you can have these kind of dependent updates. And what that means is, you don't need to learn updates for as many weights as you have in your original model. You can learn a much smaller adapter. So the main idea here is that you can learn these smaller adapters, which are captured in these A and B matrices. And the advantage now is, this might be a few hundred megabytes, whereas this could be a terabyte, hundreds of gigabytes, right? I can swap in and out multiple LoRa adapters quickly. And so this idea of parameter efficient fine tuning is really critical. And the main advantage you get from this is you can fine tune quicker. The cost of tuning these models is a lot lower, and the cost of serving and running inference with these models is a lot lower as well. So previously, if I fine tune a very large model, I would have to deploy that model and I would have to use it. So this would be one fine tune. This could be the base model, and I would have to deploy it if it's large enough on separate systems, and that costs a lot of money. Now what I can do is I can have the exact same base model, and I can bring my own adapter, that bit, the A and B matrices, and I can run my tokens through my adapter and then the same base model. And if you have your own LoRa fine tune, you can run your tokens through your adapter and then the base model stays the same, right? So you can use the same GPU to run multiple adapters on, and the inference is a lot cheaper. And it works really well. It makes fine tuning accessible to people that want to experiment and see what's working, what's not working. And this is critically important now when we're talking about agents and we have small language models that have a very specific task. You can fine tune a LoRa adapter, and then you can swap between hundreds of LoRa adapters and get access to really small specialized model that only do one task really well. And so hopefully I've convinced everybody. Um, Most of the times you don't want to do full fine tuning. You want to do LoRa fine tuning. I'm from Toronto, so all of my talks need to have at least one Drake meme in here. Right. So now that I've talked for long enough, hopefully my fine tuning job has finished. And if it's not finished, that's okay. I've got the full fine tuning team here and they can fix things. Okay, so this is completed. That's good. Because it's a really small model, it only took 7 minutes. So now what I can do is I can actually run inference with this model. Right? If you click on it, this is completed. So you can see this is that 1B parameter. This is the webinar demo fine tune. So now what I can do is I can come back to my notebook. This is the name of the model that I just fine tuned. And now all I need to do is run an inference call with this, right? So I take that model name. I can take any user prompt here, and I can run it. So this is just from the previous run that I did. But now when I run this, what it's going to do is it's going to take my LoRa adapter, and it's going to add it to the base model weights, and it's going to run my tokens through, and it's going to give us the answer. And so here you're actually running inference with your custom fine-tuned model. The really cool thing that you can do is if you have 3, 10, 25 different fine tunes, you can literally access them on the go whenever you want, right? So here I've fine tuned 3 separate models, and I can loop over and I can run inference with each one of them separately. And the first time you run this, it's going to take some time because it's going to load up the LoRa adapter. The first inference call might take some time, but future inference calls with the same model will be a lot quicker, right? So here, I'm running the same prompt through 3 different fine tunes um, in one for loop, which is pretty amazing. So if you want to run experiments and you want to see what's performing well, what's not performing well, this makes it a lot more accessible. All right. So that's a quick demo of fine tuning. So now what I want to show you is now that fine tuning is doable, it's accessible, we ran a bunch of experiments to solve some common problems that language models have. And so this is work that I did with the fine tuning team. Oh, one more thing that I forgot to show you here. So if you go to your jobs here, let's go over here. You can also look at the because I specified my weights and biases API key. You can look at the fine tuning run. Right? And so this is only 3 epochs, so there's not a lot to look at here. But if you ran it for longer, if it was an actual fine tuning job, you can actually look at the loss curves and see whether everything is looking good. All right. Right. So what I want to talk about are two experiments, two examples that we showed off to people. And this includes both notebooks and blog posts that you can look into. But the first one is this idea of long context fine tuning. And so the idea behind long context is if you don't just want to ask your language model small questions or small snippets of input, you want to test its ability, or you have very long documents that you want it to reason over. You might be surprised that it doesn't always act equally well for long context document as it does for short context documents, right? And so this was a paper that was published by Databricks, and they showed that multiple different models, open and closed, um, their behavior changes. So what you're seeing on this graph is on the y-axis, this is the accuracy with which the language model can answer certain questions from a data set. We don't need to know what data set. We can just higher is better here. And then this is the context length of the input. So they're describing these questions in longer and longer input strings, and we can see that a lot of these models, they don't perform equally well across all of these contexts. So when your context length is 4K, some of these models do really well, and then after that they go down, right? So for example, this llama 3.18b instruct, which is probably the closest to the model that we fine-tuned the 1B parameter model of this. It performs best for 4K context length, and then after that it goes down. And especially at the end here, for above 120K context length, the accuracy is about 10%. And so a lot of these models do not behave well if you just extend the context length. We can talk about why, and this is another question that I'll ask the fine-tuning team, but um, usually people say, oh, it's not been trained on these really long context lengths, right? It's given questions and answers like we showed earlier, and those questions and answers, those questions specifically are just very small statements, and so it doesn't know how to take in longer inputs. So to prove this, to prove that this problem actually exists, we ran a bunch of experiments. Um, the cool thing about these experiments is that you can run them as well. The notebook is open sourced. The data set is open as well. And if you want to follow along with this experiment, we published a deep dive blog post that you can look at here as well. But the first experiment is pretty simple. We asked the language model, I'm going to give you a really long source passage, like let's say 60,000 token long source passage. All you have to do, it's very simple. You just have to give me back the last 36 words, or the last 100 words, or the last 50 words. And so we're asking it to give us back a random number of words that occur at the end of this long passage. And so this seems easy enough. The right answer is very simple. You and I can get it. But the language model gives us this answer, right? So it gives us a bunch of gibberish, and then it says, "Oh, I can't do that for very long context length." This last part you might not always get, but you'll get this garbage output. Right? And so what we did is we found this issue. So just to prove that it doesn't, these language models can't do long context tasks, even if they're toy tasks. And then we fine-tuned it on very long context data just for this specific task, right? We gave it thousands of source passages, and the output tokens, we just gave it the right answer, right? So there's just the last n words in that source passage. And so when we did this, we saw kind of a very big improvement in performance on this simple task. And so what that tells you is you can fine tune the language model to act better, to behave better for these long context tasks, even if it's this toy task. Right? Then what we said is, okay, this is a toy task. Does it actually work for real world tasks where I have a long context problem? Right? So the second experiment that we ran for this long context problem is if I give you a very long document, you can think maybe a textbook or legal documents or financial documents. You can think of it as like a yearly statement for a large company. I wanted to summarize it and generate kind of a small 500 to 1,000 token long summary. And it turns out for this, it's also not good at this task. And the issues are probably the same. There's too many tokens that you're passing into the language model, and it's not trained specifically to handle that many tokens. And so the quality of the summary is not as good as it can be. And so what we did is we took very long source passages, both from real world data sets and then also synthetically generated source passages. And we fine tuned it for this process, and we found that it actually improves the accuracy for this task as well. If people want to learn more and even run the experiments and reproduce them themselves, again, you have the code and you have the blog post as well. I'll just share one of the results that we got here, where we fine-tuned it um, on these government report kind of legal documents. All right. So the last thing that I'll talk about here, and then we'll open it up to questions and discussion here, is we still have one problem that we haven't discussed, right? So the problem is that right now, this is what our data looks like. Our input is one string, so it could be coming from one person. They say my name is Anne, and we have one output. Right? And so the problem is there's not a lot of good conversations that go this way, right? It's usually not just one input and one output. Real conversations have a lot of inputs and have a lot of outputs. They're multi-turn. You can have interjections. One person can pause the other. One person can have a follow-up question. So typically, you have a lot of back and forth. But up until now, all the SFT data that I've shown you, it's just one question and one answer. It can be a complicated answer, but it's just one answer. There's no back and forth. So if you're building any real-world application that requires kind of not just giving the answer, but having a back and forth, so like a customer success chatbot or even problem solving where you're trying to guide it, if you have a human in the loop and you're trying to guide it towards the right answer, this type of training is not enough, right? You have to do multi-step training where you have multiple inputs and multiple outputs. And so for this, we ran another experiment. Again, so the code and the experiment is open source. What we did is we took this data set from Stanford. So this is the COCA data set. It's a conversational question answering data set. What happens in this data set is you're given a source passage that you can read, and then you have two users that have a conversation about the source passage. One is asking questions and the other one is answering those questions, right? So this can be a really long conversation, so it's typically longer context. There's a lot of tokens that you want to train on, and we fine-tuned a model on this. Specifically, what the data now looks like is slightly different. So this is one example. So here we've got one input, and then you've got the output for this, and then you have a follow-up question here. Whoops, you have a follow-up question, and then you have a follow-up answer, and then you can have as many inputs and outputs in this one data point that you want. And so when you have this data set and you fine tune on this, we also find that the model can answer questions more correctly. So from the blog, we showed that it significantly improves its performance on this COCA challenge data set, more than 3x's its performance on this data set. So if you're interested, I would read the blog and look at the experiments that we ran. Both the data set and the code is open, and you can run it yourself. All right. So with that, that's everything that I wanted to talk about. So now what I'll do is let me bring the fine-tuning team back. So let me remove my slides here. Let's bring back George, and Max has also joined us. So let me add Max to the screen as well. Hey, can you guys hear me?
Yes.
All right. So what I was thinking here, we've got 15 minutes, plus minus a couple of minutes. I just wanted to take questions from the chat. I've got some questions of my own that I thought would be interesting for the chat, for the team. But while I was talking, were there any interesting questions that you guys noticed or that we'd like to discuss here?
Like, yeah, the last question I think is quite interesting to answer. The Chirag asked about, yeah, thank you. Basically, the question about the data diversity in different stages. So I'll cover basically the 3 stages that you described. So data diversity, I think, is really important for all of the stages. So think about the pre-training that Zane showed at the first stage. So the main stage with the most of the data, it might not be that important. So even some recent papers shows that bad data is also really important for overall better understanding of the world of the model. But for supervised fine-tuning, what you aim is the tasks that you cover. So if you cover your summarization, your model should learn about summarization. And if you cover for your just general chat ability, then you have to provide really different tasks for different scenarios that you will answer. One answer, multi-hop scenario where you can get the answer, then another question, another answer. You cover different lengths, different. So there are objective metrics that you can measure. For example, variability of your outputs, and it should be normal distribution. You can measure the quality of your outputs. So you can measure for the repetitiveness. It's similar to the recent webinar that we had also about the pre-training. So you can measure the quality using the same methods for supervised fine-tuning. But I think both diversity and quality are really important. But I think you should cover basically use cases that you use your fine-tuning model for, and try to think out of the box what might happen when you use your data. Don't just fixate over one task or one simple scenario that you use for your fine-tuning. Try to cover most of them, and try to cover them with like quality over quantity.
Awesome, thanks. There's a lot of interesting questions, so let me take this one. There's a question, they're specifically interested in tool use for specific SDKs or APIs. What do we think about this?
If no one else wants to answer, I can speak a bit to it. So in general, there is definitely a way to adapt the model for specific SDKs. And the question is how you aim to use that model later on for like SDKs or APIs. So if I understand the question correctly, you should have some kind of a format or like some kind of a structure that specifies how the inputs to that SDK or an API are given. So you could, for example, tokenize the data in that way. And depending on how you use it later on, so like it's either via Together or via some other inference tools that you use, which is also possible with the fine-tuning API, you can basically like supply the data in such a way. So because SFT is at the core is the same next token prediction as what you use in other case, this unlocks the exact same use case that you asked about. So in general, the answer is yes. Obviously, there are quite a few details, and probably at some point we'll release sort of tools or features to help you out with this. But in general, this is indeed very much possible, even with the current shape of the fine-tuning API.
I could add a little bit of this question. So basically, yes, small models, especially Llama 3.2 that we support, is really capable for function calling. So it's usually enough for such kind of tasks, and it's also faster and cheaper to run. And the second one is for function calling specifically, it's important how you format your data. So Zane also showed how this messages format look like. You have this user and assistant roles in your list of the messages that you have. For tools, you have to use specific tool role. And in that content, you use the function definition of your function in a Python, for example. And it's usually enough for models to understand that you're going to use this tool.
Awesome. This is an interesting question. So this next question is about balancing number of epochs versus bigger or smaller data sets. I think this is a very common question that people think about. So let's comment on this.
Yeah, good answer also about that. So it's to understand that question correctly, you have to also understand the notion of critical batch size. I could simplify this a bit, but basically, if you have really large data set, it's usually better to train for just one epoch. If you have smaller data set and a small model, it's usually better to train on more epochs. So the meaning basically is not only the dataset size, but the number of iterations that the model will take. So you have to understand that if the model can run with really large batch size, it doesn't benefit from training on a small dataset. So you have to increase the dataset size. But when you increase dataset size, it's usually better to also increase the model size. So there is a trade-off. If you increase your dataset size and you increased your model size, you probably have to try only for one epoch if it's like really large, it's at 1 million plus samples. If you don't get enough quality, you can try more, but usually better off increasing dataset size even more and still sticking to one epoch or something like that.
Awesome.
I would like also to add to the answer that George gave, that it also might be that having more data needs are much more expensive than training on more epochs, because while you're getting in your data, you're asking for more data points from your customers or maybe from your assessors that writing down your answers. So it might be just useful to experiment a bit and find out what the best solution works for you.
Yeah, that's a good point, because the data is not free. You have to pay contractors to generate the data. And this is why a lot of people are looking into synthetic data generation. But even that synthetic data generation, you have to tell it what the example should look like. So that can cost significantly more. Right. There's another question about, I think this is specifically about the Together product. Once they fine-tuned a model, can they bring it to their cloud or even run it locally? Yeah, Max, go ahead.
I will give a very brief answer. Yes. So after you fine-tune your models using the fine-tuning API, you can download them, and it's exactly the same checkpoint in the Hugging Face format that you can use later on in any of the applications you have. So you can deploy them locally, you can convert them to GGUF, you can deploy them somewhere else. So yes.
Awesome. Another probably popular question here is there any way that you can fine tune to reduce hallucinations?
I mean, that's a tricky one. So usually when people fine tune on our platform, they use already instruct version of the models. And usually by fine tuning, you either improve the tone or add a new task or improve the tool usage. So you kind of add something to it. And the hallucination rate is usually how the knowledge was transformed in the post-training phase of the existing model. So the problem might lie here. But even though it's still possible to decrease hallucination on a specific task, for example, if the model is not really good on summarization, it produces hallucinations. It just randomly generates answers without relating to the context. Then you can, of course, improve over that. If you have really good quality of the data, then and train carefully, then it's probably like hallucination will be much lower. But you will not kind of remove 100% of the hallucination in that way still.
There is an interesting question. Oh, yeah, I guess we can take this one. Sorry, Zane.
You want to answer that?
I think that Zane is muted.
Oh, sorry about that. Yeah, so I was saying, this is the question you meant, or there's another interesting question here?
Another one. How effective is fine-tuning and guiding the model?
Oh,
Well, we can also answer this one.
we'll take this one, and then we can take that one, yeah.
Yeah, sure. So what are the ways to evaluate the accuracy of a fine-tuned model inference at scale? So if I understand the question correctly, the idea is that we have fine-tuned the model, and now we want to evaluate it somehow. So like, is it actually better at the task that we are interested in, or we need to do something else? So, well, I could try to answer, or maybe George, you have some ideas about it.
So sneak peek, we're already working on the feature that will support evaluation in the future. It's not currently public, but yeah, it will be possible to run evaluation at scale on our platform for fine-tune model or any other model as well.
Yeah, but like in more generality, obviously, when you're fine-tuning on a particular task, there is a question of how do you like how does that model actually solve the problem. So one thing you could do with Together immediately is to use the validation dataset, which will compute the perplexity on a held out number of examples that you can also upload to our platform, and will give you some idea of how well the model generalizes. In more specifics, I think evaluating the accuracy of a model for your specific task comes down to essentially building your own tailored benchmark for this problem. This is a very actively studied research area, so we will not be able to offer like the best possible solution here. I think like um, communities and companies like Hugging Face are very actively working onto this. But in general, the idea is that you want to synthesize the kind of knowledge or like the kind of skills that you're trying to teach to the model, and then come up with a sort of like test set or an exam for that model that would also cover a sufficiently broad number of examples, and then try to see what's happening when you ask those questions to the model before fine-tuning, for example, to the base model, and then what's happening after you do it. Obviously, you have to do a lot of iteration here when composing such a data set, because it's quite difficult to arrive to the best possible shape. But at the end, you'll end up with something that nearly exactly corresponds to the problem that you are trying to solve. So I would say that this is probably one of the best ways. Obviously, you could just use something like another LLM. So like you could ask the model some questions and see if another model, maybe a better or stronger one, rates the responses of a new one higher. So these are just a couple of ideas for this.
Yeah, there's also, I'll share afterwards, there's a really good blog post on this LLM as a judge use case. Jed, if you're interested, just send me a message. I can link you that as well. Let's get to this next question, Max, you were talking about.
Yep. So the question is, how effective is fine-tuning and guiding the model to interpret content and extracting specific information? For instance, entity extraction within a specialized domain of text. I would say that out of all, out of a huge variety of possible use cases of fine-tuning, this one is probably one of the most straightforward ones and one of the most effective ones. Because essentially, if you're familiar with the process of LLM or foundation model training in general, this is nearly exactly what happens at the instruction fine-tuning stage for the base model. So you want the model, in this case, to respond to the queries of the user in a particular way, because the base model can just continue string the input string in any possible manner. But now you have some constraints on the format of the model based on how long you train on this number of examples. You can enforce it to be more strict in the format of its replies. So like instruction fine-tuning is again a good example here. And also, as Zane said during the webinar, adapting the model to a new domain is actually one of the best possible use cases for fine-tuning, because you essentially want the parameters of that model to be aware of the fact that you are now working with this particular form of data. Obviously, you could do this with some other ways, for example, even with prompt engineering. But fine-tuning essentially ingrains that information inside the weights of your model. So you no longer have to play around with the prompt, like you automatically, by design, basically build in that information into the new weights of your LLM. I hope that answers the question.
Awesome. I think we have time for one more question, and then we can let people go. Do you guys have any preferred questions? There's a couple that I'm looking at. There's one question that's asking about fine-tuning base models versus instruct models. So I guess the idea here is, why shouldn't I take a base model that's just unsupervised, next token prediction tuned, and then run my own instruct tuning process versus take somebody else's instruct tune model and then try to instruct tune that. So what do we think about this?
I may know the answer, or kind of the answer for this question. It depends on what kind of data you train it on. For example, it might be something that already instruct model was trained on, something specific for math or for coding. There are a lot of instruct models that were trained on it. Or maybe it's a model, or it's maybe a data that were another specific data set, like, for example, a different language. And most of the instruct models trains on English, maybe on Chinese, or maybe any other major language. But if you need a model that's more specific for Spanish or for any other language that has not a lot of data, but you have training on such a data with instruct model may make it worse than you will try to train on the base model, which not forgot what the language are and how they works on.
So I guess it depends on what type of instruction tuning the creators of the model did to release, whether you want to instruct tune on top of it or whether you want to do it on top of the base model, right? Awesome. So let's, I think we're at time over here. So let's end the discussion off. I wanted to end off thanking everybody. Thanks everybody for their time. Thank you for tuning in. Try our fine tuning API. Try it if you have a specific problem, if you just want to learn about it, and reach out to me if you'd like to discuss. Another thing that we're going to be running a lot more of these webinars. We've got another one on agents that's coming up in a couple of weeks here. If you want to see a webinar, if you're interested in a particular topic, you can add in the comments of this video, or you can send me a message. And if there's a topic that's popular enough, it can be a detailed topic. It doesn't need to be general, like fine tuning. It can be very specific. If enough people are interested, we can put different researchers, different teams. We can bring them and then help answer your questions. Right. Thanks, everybody. Thanks, team. Take care. Bye-bye.